Hello, this is acid and base neutralization part 2, and today we're going to focus on acid and base neutralization calculations. So a little bit more background about acid and base neutralization. I know I talked about eating Tums, which is a base to take care of heartburn, which is caused by too much acid in the stomach, but there's another couple of examples that are probably more applicable to you. One is teeth brushing. So all the little microorganisms in your mouth will actually end up producing an acid when you eat food. And so the reason why you have to brush your teeth is that the toothpaste is basic. So you need that basic toothpaste to neutralize all the acid in your teeth. And that's going to end up preventing tooth decay. Another one is shampoo. Shampoo tends to be acidic. And if you notice, after you wash your hair with shampoo, it tends to be really rough. Afterwards, you not rinse, you put on a conditioner that's basic, and that's going to neutralize your acidic shampoo so that your hair feels nice and smooth afterwards. All right, so back to some review on acid and base neutralization. So this is from the PowerPoint before. Keep in mind that the moles of acid have to be equal to the moles of base in order for neutralization to occur. And so what I have represented here, again, is my 4 moles of HNO3, that represents 1 mole each, and my 4 moles of LiOH, and that's 1 mole each. And only when you have equal moles will the hydrogen all combine with the hydroxide from the base and create water. And that gives us a pH of a solution 7. And don't forget that the other product that's formed, the leftover cation from the base, bonds with the anion from the acid, and that's going to give us something called a salt. And that's just the ionic compound resulting in an acid-base neutralization reaction. And where we left off last time, we were writing equations for these, and I just wanted to show you another one. Sometimes you don't have a perfect one-to-one hydrogen hydroxide ratio. So here's an example of one. So if I took sulfuric acid, H2SO4, and tried to neutralize it with lithium hydroxide, you'll notice that each sulfuric acid actually has 2 ionizable hydrogens, meaning it will produce 2 hydrogen ions. It still produces water, and you still get lithium sulfate, but don't forget to balance your charge in this case. But because every sulfuric acid produces 2 times as much hydrogen ions, you actually need twice as much lithium hydroxide to neutralize it. And so that's why we have to balance that equation down here. You can look at the Li2SO4, Li2. That would make us put a coefficient of 2 in front of the LiOH, and that produces 2 times as much hydroxide, so we need to make sure we balance that with the 2 coefficient on the right-hand side. Okay, so just keep an eye out for those. There's not many where you have a 2-to-1 ratio like this one, so most of them are actually 1-to-1 ratio. So let's look at some of the calculations you could be doing. We're going to start off with something basic. So this one just gets at the idea if you need to neutralize an acid and a base, you have to have the same number of moles. Okay, so that's what these questions are going for. So we'll look at the first question. How many moles of base is required to neutralize 500 milliliters of a 2.4 molar hydrochloric acid solution? Okay, so you know that this information pertains to the acid. We have hydrochloric acid, its concentration is 2.4 molar, we have 500 milliliters of it. So if we can figure out how many moles of acid we have, that can tell us how many moles of base we need to neutralize it. So we actually need to pull up this equation. This is a modified molarity equation, so this allows us to solve for moles by multiplying molarity times volume. So molarity I'm going to highlight pink, volume I'm going to highlight green. Okay, so to figure out the moles of hydrogen in HCl, all we need to do is to take the molarity of the acid and multiply it with the volume of the base in liters. And that's why I changed it to 0.5 liters. We can't do 500 milliliters. Okay. Once you multiply the molarity of your acid with the volume of the acid, you can get the moles of acid. And that will tell you how many moles of hydrogen ions it will produce. If you look at the formula, there's 1 hydrogen in HCl, so it's going to produce the same amount of moles of hydrogen ions. And that tells us we're going to need the same amount of hydroxide ions in order to neutralize it. Okay, so here's another one. I just flipped it. How many moles of acid is required to neutralize 1.3 liters of a 0.5 molar sodium hydroxide solution. So we have a 0.5 molar sodium hydroxide solution. We have 1.3 liters of it. Again, first we need to figure out how many moles of hydroxide are in NaOH. And that will tell us how many moles of acid we need to neutralize it. So take your moles. You're going to multiply your molarity times the volume. In this case, you don't have to change anything. Molarity is given to you, and the volume in liters is given to you. So if you multiply the two, you get 0.65. That tells us that we have 0.65 moles of sodium hydroxide, and that will produce 0.65 moles of hydroxide ions. And that means we're going to need 0.65 moles of hydrogen ions to neutralize. Okay, so these problems, all they do is they get at the idea of moles of acid have to be equal to moles of base in order for neutralization to occur. And we can actually take that piece of information and solve another type of problem with it. So this is a new equation I'm going to introduce. Sometimes you'll hear it as MAVA-MIBVIB, but the MA means molarity of the acid. VA is the volume of the acid. We have molarity of base equals volume of the base. Okay, so if you think about it, if you multiply molarity times volume, I'm going to go back to this slide. This slide. So if you think about it, if you multiply molarity times volume, that gives us moles. Okay, so that means if we take the molarity of the acid times the volume of the acid, that gives us moles of acid. If we take the molarity of the base times volume of the base, that gives us moles of base. So if moles of acid is equal to moles of base, then molarity times volume of acid must be equal to molarity and volume of base. So these problems, what they sound like, is a little bit more complex. Now you get three pieces of information. So if we look at this one, what volume of a 1.5 molar sodium hydroxide solution is required to neutralize 600 milliliters of a 0.5 molar hydrochloric acid solution? Okay, so one thing you don't want to do is autopilot these problems in any way, shape, or form. You have to dissect the information that you have. So what you see that I have down here as I broke down the information into acid information and base information. Okay, so here's my acid, hydrochloric acid. There's my molarity. There's my volume. So I just sorted it here. Volume is 600 milliliters or 0.6 liters. Molarity is 0.5. Volume will be in pink. Molarity in green. Here's our base, 1.5 molar of sodium hydroxide. So we have the molarity, 1.5 molar. What volume? So we don't know that, so there's my question mark. Okay, so now I'm going to use the MAVA equals MBVB equation. All right, and all I do is I substitute in molarity of the acid, volume of the acid, those are going to be multiplied, equals molarity of the base times volume of the base. And what you do is you isolate VB, in this case, will look like that. And then top, multiply the two, divide by what's on the bottom, you're going to get 0.2 liters as your volume of base. So if you think about that, this is less concentrated. This is more concentrated. Okay, we should need less than 600 milliliters to neutralize that acid. Okay, because this is more concentrated, it's going to have more hydroxides per unit volume. And so that actually confirms your answer. It's less than 600 milliliters. Okay, here's another problem. What concentration of 500 milliliters of a base is required to neutralize 1.6 liters of a 0.75 molar hydrochloric acid solution? Okay, so what you want to do is you want to pick apart your information again. Don't just start autopiloting and putting things in the problem to solve. Find your acid, hydrochloric acid. That's my molarity. That's my volume. So I'm going to sort that here. Volume is 1.6 liters. Molarity is 0.75 molar. There's my base, 500 milliliters of it. There's my volume, 0.5 liters. My molarity, what concentration? I don't know. Okay, sort your pieces of information into the equation. You'll see I have molarity of acid times volume of acid. I don't know the base molarity, so I'm going to leave MB, and that's going to be my volume of the base. Isolate for MB. You're going to take 0.75 molar times 1.6 liter divided by 0.5 liters, That should give you 2.5 molar solution. So your base has to have a concentration of 2.4 molar. Okay, so if you look at this, I have 1.6 liters of a lower molarity acid, and I'm going to try to use less base to neutralize that acid. So if I need less base to neutralize way more acid, that base has to be more concentrated. And so that's why you get the 2.4. Okay, so that checks out. All right. If you do have any questions on these, please, I've got tutoring twice before you take your test. You can also email me if you need help. I know sometimes these calculations can get a little bit hairy. So if you need help, please don't hesitate to ask. Thanks. Bye-bye.